Hey guys, this is Craig Migliaccio from acservicetech, and today I just got back from a visit down to Florida with my good friend Brian Orr from HVAC School. Nice and warm down there, frigid and freezing up here in New Jersey. But anyway, we're going to be going over recovery tips, and now we're riding into the Kalos junkyard where we're going to talk about field practices for refrigerant recovery. I'm Craig Migliaccio with acservicetech.
And I'm Brian with HVAC School, and we're going to talk about some best practices for getting really good results with recovery to make sure that you get the refrigerant out and you don't cross-contaminate or do anything crazy like that. And Craig has a lot of good tips for that.
So the recovery bottle, it really starts with your recovery bottle. You know, if you're taking a recovery bottle from maybe a fenced-in area within the shop, and maybe you have 10 recovery bottles there, you got to first make sure you know what refrigerant's in that bottle. You also need to make sure if that refrigerant is contaminated. If there's too much air in that bottle, you're not going to be able to pump refrigerant from the unit into that bottle, and basically your recovery machine could go off on high limit, and you really don't want to ever be using refrigerant out of a bottle that's contaminated anyway. Now, via the EPA standards, we're not supposed to really be charging units with refrigerant from a recovery bottle if we're pulling it out of multiple systems. If we pull refrigerant out of a system, we could potentially reuse it, but it's always best to use new refrigerant, just to make sure that you're not recontaminating the system that you're working in. But one thing I just want to make sure that you're aware of is to make sure that also the tank is not too full and you're trying to basically overfill it, and that would potentially be a dangerous situation, especially when that tank ends up, the surrounding air temperature is high, and basically you have the expansion of the refrigerant, and you have no room for the vapor within the tank.
Yeah, and that's what we call hydrostatic pressure. So the goal would be, even in a worst case scenario, to make sure that you don't fill the tank to over 80%. Right. The thing that throws a lot of people off and really makes this difficult is that the tank has a WC printed on it, which is water capacity, but of course we're not putting water inside the tank. So you have to do some math in order to figure out how much refrigerant can you put in the tank, and you can go to my app, the HVAC School app. It's free, and there's a calculator in there that you can plug in different refrigerants. You can calculate based on the tare weight and the water capacity what the fill should be in the tank, and then what your maximum total tank weight should be. And generally speaking, it's kind of an accepted trade practice that we use 130 degrees as sort of the maximum temperature. That's sort of the worst case scenario in the back of your van, at least hopefully, if you're not working in Death Valley or something like that. Even though the AHRI standards talk about 77 degrees kind of being the test standard. But again, without getting too horribly nerdy with this, we just want to make sure we don't fill the tank more than 80%. That's no bueno.
Right. Basically, when you hook up a recovery machine, you want to make sure that all of your hoses are snug, but you don't want to crush the rubber on the hoses onto the port connections. So you're really closing down the pathway, but as well, you don't want them too loose to where they're vibrating or something like that during your recovery, and then all of a sudden you're pulling air into your recovery machine and then forcing it into that recovery tank. So another thing to keep in mind is that you want to monitor the amount of refrigerant going into that tank. And so first you want to know how much refrigerant's in the tank first, and you can look at the factory charge on the unit to see how much refrigerant you're going to be putting into that tank. You may need to basically top that tank off at 80% and then switch tanks, or you may just want to do one recovery with one tank, and so you want to kind of plan that out depending on how much refrigerant's inside the system that you're working on.
Yeah, and that's really simple to do in order to calculate how much is in the tank, because the tank has stamped on it its TW, or tare weight, which is its empty weight. You just compare what you actually measure with a scale to that tare weight to know what's in the tank in the first place. To go back quickly, though, you also want to know what refrigerant's in it, and that's where just connecting a gauge to the tank, comparing it to a PT chart, to a known refrigerant based on, generally speaking, it's going to have on there what the tank has in it, hopefully. But either way, that's probably an assumption on my part. But hopefully you know what's in the tank, or what's supposed to be in the tank, and then you can compare that to your PT chart or to the saturated curve on your gauge in order to make sure that you're not going to, again, have more work than you need, and then also not mixing refrigerants. That's also really important.
So if this is in your shop, you really want to make sure that it hasn't moved its location, and the temperature surrounding this tank should be steady for several hours in order to do that. So you'd go ahead and hook your gauge up to the tank, and take a temperature reading of the air or the actual tank itself in order to basically match the saturated temperature on your gauge or PT chart to the temperature surrounding the tank. That's how you know what refrigerant it is, if it's R22 or if it's R410A or whatever the refrigerant is. So you got to make sure that you're not mixing refrigerants because that's no good. You're not going to be able to end up reclaiming that at the factory. So.
Yeah, it's costly, and is one thing, and also we're not supposed to mix them based on EPA standards. Another thing that you mentioned that I think is worth reiterating is that can you take refrigerant out of a system and put it back into the same system? The answer is yes, you could. Generally speaking, I would not suggest doing that, and there's a couple reasons. First off, you don't know what was in that system unless you were watching it from soup to nuts. You don't know if somebody put some sort of additive in it, or who knows. Maybe they didn't pull a good vacuum, and so it could be contaminated with moisture. There could be oil in that refrigerant that's been broken down via hydrolysis if it's POE or something like that. So just a lot that can go wrong, besides the fact that when you get a tank that is not brand new, so meaning it's gone through a reclaim facility, they do not clean out those tanks. So there could be sludge down to the bottom of those tanks, and we've actually cut them apart and found that there is, and so you could potentially be putting some nasty stuff back into somebody else's machine, even if the tank was empty. Also, another thing that I forgot to mention is if the tank is empty, you need to make sure that you pull a vacuum on that tank first as well.
Yeah, absolutely. And so, and to Brian's point, you do a lot of work working on the system. So you're recovering the refrigerant now, you're replacing a component, maybe it's a filter dryer, maybe it's a TXV or some other component within a system. You're doing all that work, so why would you put the old refrigerant back in there again? You want to take that from a virgin bottle whenever possible, so that's definitely what you want to do.
So when you're working with a recovery bottle that is empty and you're going to put some refrigerant in it and you know there's nothing in it whatsoever, you need to pull a vacuum on it first. It's really easy to do. You just hook a vacuum gauge. Generally, we're going to use a large gauge hose, go from here to the vacuum pump, and then you can literally just hook your micron gauge. You need to have an adapter here. You can just hook your micron gauge with an adapter up to the other side and measure that pressure. Now, generally speaking, if you want to pull a vacuum quickly on a tank, the easier side to do it is on the vapor side because the vapor side doesn't have a dip tube. So there's less restriction on the vapor side than there is on the liquid side. So you can hook your micron gauge on the liquid side, connect there, pull a deep vacuum on it, get it below 500 microns, and then you're ready to go ahead and put refrigerant into the tank.
Yeah, and I would advise you to do that right before you're going to be recovering refrigerant into that tank. I wouldn't recover it at your shop, or I'm sorry, I wouldn't vacuum this recovery bottle at your shop and then close the valves and then take it to the job site and then think you're still holding vacuum. I would do that on the tank right before using it and adding your refrigerant into the recovery bottle here. So this can be referred to as a recovery bottle or recovery tank. Now, the other thing is that you want to make sure that when you're hooking up your hoses to the system, you want to remove the valve cores. You want to remove any restrictions that are going to slow your recovery down. So you want to get all that refrigerant into this tank. You want it to be quick, but you also want to get all the refrigerant out of the system.
Yeah, and that's why having a couple core tools is really, really important when you're going to recover refrigerant, because it's just going to make it so much quicker. And then when you have your cores out, that's also going to make it easier to pull your vacuum afterwards. So get your cores out, leave these core tools in place when you're recovering. That's what a lot of people, the mistake I see happen a lot, is they think that they've got to pull the core out and then get the core tools off. Leave them on through that whole process, and then you're just going to connect to this back side. This is where you're going to connect for recovery. This is where you're going to connect for your vacuum with this in place with the core out. And now you also have that added benefit of having that control in place. So very simple. Pull those out. It's going to reduce the amount of impedance to the refrigerant flow. It's going to make it go quicker. But then also, let's talk a little bit about keeping the pressure low in the tank as much as possible to also speed up that process.
So what you can do is you could put this in maybe an ice bath, something to lower the temperature of the bottle, and you could even do that without a recovery machine if the tank is at a lower temperature than the temperature of the unit. Refrigerant is going to be going from the higher pressurized area to the lower pressurized area, and so you could recover partial of the refrigerant right into the tank that way. But you just want to make sure that you get all of your hoses connected and purge the air out before doing any of this stuff.
Yeah, get the air out of the hoses for sure. You don't want to contaminate your refrigerant more during this process. And also, I really liked your tip on the vacuum right before you're going to use it. That's a really good point. And the reason is that everything leaks under deep vacuum. Right. Deep vacuum, you're dealing with such a fine scale, and all of these threaded connections over time will begin to leak, and you will end up not having as deep of a vacuum before you're ready to put the refrigerant in it. So that's a really, really good tip. Another thing in terms of keeping the tank cool, some people will put it in a bucket of ice, whatever, but keep in mind that when you're doing that, you still have to keep weighing it, and that gets really tricky when you're taking it into a bucket of ice. So you need to periodically pull it back out. Now, you can generally have a sense of whether or not you're overfilling. You know whether you're getting close or whatever, but you need to still keep weighing it. Having this scale out from the very beginning, just making sure this sucker's out and ready to work with, is a really big thing anytime you're doing anything, anytime you're charging into a system, anytime you're recovering from a system, because it's also going to be really telltale if, say, you're replacing that compressor and when you're recovering the charge, you find that the system only has half the refrigerant it's supposed to have. Well, now you better look for other leaks in the system before you go ahead and slap that new compressor in. Or if it has double the charge it's supposed to have, now you want to look to see if you have an airflow problem because somebody was probably compensating for something else by adding too much charge. So this scale is really key. Another thing that's nice, if you use a scale that's water resistant, that's nice because you're going to have the water going, and then you can even use something like a garden hose, or even, I don't know if you've seen the Supco Cool Presser. It's got the magnet on it. That's actually a neat little tool because you can just stick it to the tank, and then you can run a little bit of water over it, and then that way you don't have to have the ice bucket. Because if you're dealing with a tank, a larger tank like this, you're not going to be able to fit it in an ice bucket anyway.
Yeah, I used to have, back when I started, I would give my recovery bottle a nice cold shower to try to cool it down. So, you know, you gotta monitor those things. But really, if you are not getting any air in the recovery bottle, your recovery machine should be able to add all that refrigerant into that recovery bottle without it going off on a high pressure limit because the tank is too high of a pressure. You can go ahead and do all this in one shot. And Brian makes a great point. I always recommend that your recovery bottle or even a virgin refrigerant bottle is on the scale the whole time. You're monitoring it, because just because the factory charge says one thing doesn't mean that's the actual amount of refrigerant that's going to be going. Go into the tank or into the system in the case of a virgin bottle.
Yeah, a good thing to think about in general, just in terms of overarching, thinking about getting things in and out of a system. If you want to get refrigerant out of the system, then the best thing to do is to keep the system as warm as you can and keep the tank as cool as you can, right? So don't put the tank in the middle of the sun. You know, if you can put it in the shade, put it in the shade. These are obvious things, but you're trying to get stuff out of the system because higher temperature equals higher pressure. You want the system to be higher temperature. You want the bottle to be lower. If you're doing the opposite, if you're trying to put refrigerant into the system and under low ambient conditions, then you do the opposite, right? You try to keep the tank warmer. You could use a heating blanket or something if you're charging. So just thinking about that can be helpful. Same thing is true of vacuum. If you're trying to get molecules out of the system, then heating the compressor with a heat gun or the accumulator where there might be some refrigerants, you know, entrained in the oil and stuck can be helpful. So always think about that. Are there cases where it might be advantageous to maybe heat some things in order to try to get some refrigerant out? You know, maybe. And you actually talked about this a little bit in terms of, you know, running the blower as well, which is another really good thought.
Yeah, inside the building, it's usually above 32 degrees. You know, inside the building, especially if it's conditioned all the time, you're going to be around 70 degrees. So you can run the fan. I always advocate, hey, run the fan during a vacuum. Run the fan when you're recovering refrigerant, because when you're recovering refrigerant, you're lowering the pressure inside the system, and you may have some of the liquid is not basically boiling off into a vapor unless you add heat to it. So you may think you're all the way down at 0 PSIG, and then you shut your recovery machine setup off, and all of a sudden the pressure rises. Well, why not just turn the indoor fan on during that time? So it's something real easy to do, and you don't have to worry about turning your compressor on. In fact, if you have a split system, you can pull the outdoor disconnect and still and that makes sure that that compressor is not going to accidentally get turned on, and then you go over to your indoor thermostat and turn the fan on.
Again, the idea is to get all the refrigerant out of the system. When you talk about EPA standards, most of what we work on, and again, I'm making a big assumption here because some of you may work on low pressure refrigerants, but most of what we work on are high pressure refrigerants in air conditioning. So that's a quick caveat. But really, we generally just need to get the system to atmospheric. That's also advantageous because when you pull a system below atmospheric, if there's any leaks in the system, you're going to pull air in. So we really want to get it to 0. But we have this challenge that you're sometimes pulling refrigerant out and then as soon as you valve it off, the pressure starts rising again. A lot of guys will notice that. So what tips would you give there?
So you first want to kind of know, well, do you have a leak on the system? You know, do you have a low refrigerant charge, or is there a possibility that there's a leak? Because even in the EPA standards, they say, hey, don't pull it down below atmospheric pressure. Don't pull it down below 0 psig, or you're going to be pulling air into the system through the leak spot, and then you're going to end up contaminating the refrigerant in your recovery bottle. So you just can't do that. Now, if you see an accurate charge and you want to pull it down a little bit below 0 psig, you can go ahead and do that. But once again, I advocate that you're going to end up putting some type of heat on the system, and a good place to do that is at this big heat exchanger here, so that once you get it down below 0 psig, it ends up, the whole system is shut off and it rises, but it doesn't go above 0 psig. And so that will be great if you can just do all that in one shot. And the problem here is when it ends up rising and you have to go back and try to recover the rest of the refrigerant that has vaporized.
Yeah, you want to make sure that it stabilizes. Yeah. That's the big thing. And so when you're pulling it down, you only have to pull it down to 0. Right. And again, if you have a leak, don't pull it down below 0. But you know, if you have no reason to believe you do have a leak, if you pull it down to 0, you can sometimes go a little deeper than that, valve it off, and just make sure it doesn't keep rising. Right. This is especially true when you're pulling on the entire system, including the compressor and accumulator, because the compressor and accumulator have oil in them, and that oil tends to hold liquid refrigerant. And so when you have that liquid refrigerant that gets, you know, entrained in that oil, sometimes that boils off slowly. And that's where, when you are pulling on the whole system, heating the compressor and accumulator is also a good thing to do. Yeah. If you have crankcase heaters, you can sometimes make sure that those remain on during that process, and that can also help drive out some of that refrigerant.
Yeah. Let's talk about the refrigerant hose setup. So you want to end up having the largest recovery hoses possible. So you want to make it a fast recovery, and this goes to the point of heating the system up. If you have a fast recovery, it doesn't give necessarily the liquid a chance to boil off, but that's why it's important to add the heat load. But you can recover real quickly. Instead of it taking an hour, you know, it can take 10 minutes, 5 minutes, you know, and that's the thing. And so you don't have that amount of time to be sitting there for an hour and a half while leaving the valve cores in, just trying to get the refrigerant out. And sometimes there's not enough space really to get your valve core removal tool in there and pull the valve core completely out, but you can then hook on to the side port of a valve core removal tool. At least you're getting the valve core out of the way in order to try to get the restrictions out so you can recover your refrigerant quickly.
Yeah, and so pull from both sides whenever possible. You know, hook one hose to your liquid line, hook one hose to your suction line. Again, typical split system type of setup. You can tee those together if you want right before you go into the tank. Again, using larger hoses helps. Some people will point out that you know, your recovery machine, it is a good idea to put an inline filter dryer in place. The point of that is really to protect your machine. I mean, that's the point of it, because you're not going to clean dirty refrigerant in one pass. The filter dryer in a system can dry and clean that refrigerant because it's gotten multiple passes. Now, let's say there is a case where you have a large amount of refrigerant that you've pulled out of a system and you don't want to waste it and you're going to put it back in because your employer told you to, or whatever the case may be, right? That happens. And in that case, when you take it out, you want to run it through the inline filter dryer, and then when you put it back in, you want to run it through an inline filter dryer as well, because at least that gives you protection against solid contaminants and that sort of thing. Certainly not going to dry out, you know, wet refrigerant completely, but it can help with keeping it a little bit cleaner.
Now, when you do hook up your hoses, you want to purge all of the air out of the hoses before you start your recovery, and sometimes people do a vacuum on that, but what you can do if you're just purging the air out, you can do it over at your recovery tank. And so basically you have your hoses going to your recovery machine, and from your recovery machine you have a semi-short but still large hose going to your recovery tank, and at your recovery tank, that's where you're going to purge the air out from the hoses before you then close your hose back down onto the fitting and open up your recovery tank to get ready for the recovery to start.
Yeah. Absolutely. And that's another nice thing about having core remover tools on, is because it just gives you a little bit, you know, if you make a mistake along the way or whatever, it gives you a little quick shut-off ability, which I always like, because I'm prone to making mistakes.
Here's a question that a lot of people seem to ask is, what are you doing with the refrigerant that's in the discharge line of the recovery machine where it connects to the tank at? And the problem with that is there's there's no way to recover that refrigerant because it's your tank is at a higher pressure than whatever the hose is. So on the inlet of the recovery machine, that should be at atmospheric pressure, but you're still going to have that refrigerant in the hose, and unfortunately that's going to end up getting vented unless you have another recovery bottle or something like that at a lower pressure, but that would end up falling under the de minimis rule. We don't want to vent refrigerant, but we've done our absolute best to try to get all the refrigerant out of the system and into that recovery bottle so we don't end up venting that refrigerant into the atmosphere.
Yep. Some machines have a purge mode,
yes.
So that way you're purging the refrigerant out of the condenser. It kind of repipes everything, so that way you don't have that. But all of that has been reviewed by the EPA. It's not like the EPA doesn't know how these things are made. Right. And so again, our goal is to do our due diligence so that we are not intentionally venting refrigerant. Beyond that, the little bit of loss that you have with disconnecting and purging, or that little bit that's in between the recovery machine and the recovery tank, those are all acceptable as long as you're not doing any, you're doing everything you can do to prevent the venting of refrigerant.
And I always try to keep that hose short. There's no need to have a 5-foot hose going from the recovery machine to the recovery bottle. There's no reason, because in the end that's going to have refrigerant in it. So why not make that a short hose, if at all possible? So that's just another quick thing on that. So.
In terms of residential recovery, my advice would be, if you find that you're spending a lot of time doing it, it's taking you a long time, then you're probably doing something wrong. There's probably something in your process that you can improve, either by removing the coolers or maybe use larger tanks. And that's another thing. Some people are always using the smaller tank sizes. And if you are working on a 5-ton piece of equipment, for example, that's holding potentially 20 pounds of refrigerant, that's probably not your best bet. So it should be taking, again, in general, most of the systems we're doing, because we do a lot of change-outs, typically our recoveries take 10, 15 minutes. That's going to be typical. If you're finding that it's taking an hour, well, then there's probably something going on there. And that also increases compliance, too. If you have the proper tools, and I'm talking to your contractors out there, if you have the proper tools and you have the proper practices, it's going to be much easier to do things the right way. But always, always, always make sure that you're using a scale, make sure that you're not filling above 80%, and keep refrigerant uncontaminated. Keep it from being mixed, keep air from getting into the system, and if you do all those things, I think you're going to get a pretty good result.
Yeah, so you're going to have several recovery tanks in the truck, and each one's going to be a different refrigerant. And I know it's harder to keep 50-pound recovery tanks in the truck, but if you're just going around with the 30-pounders, the smaller versions, even, they're not exactly 30, and these aren't exactly 50. They're less, but they don't have a lot of capacity in them, and you're going to overfill, or you're going to have to change out. You don't want to overfill them, and you don't want to have to stop your recovery process and switch out the tank for another one. So you want to make sure you have all that on the truck when you're doing all of your service calls. You don't know what you're going to run into out there in the field, so you want to be prepared, and also you want to have confidence in your recovery setup. So a lot of us, we end up having our individual recovery setup, our individual vacuum setup, ones that we know are going to work well for our needs. We're not, trying to search around for some spare tool somewhere. We want to be set up and prepared in advance. So.
Absolutely. And another good thing is keep some manila toe tags, which is what we used to call them, with the little wires ties on them. And that way you can write what you put into each tank. Now, you're still going to know how much weight you have in beforehand by using your scale, but at least that way it ensures that you are kind of keeping tabs on it and where that refrigerant came from. If you are working in cases where you are removing systems from commission, you also need to keep a logbook of how much refrigerant you took out of that equipment, where it came from, and the models and serial numbers of that equipment. So you have to have some way of doing that. In regular service, that isn't necessary for the kind of the smaller stuff that we work on, but it's just a good idea to do anyway. You're keeping tabs on yourself. Yeah.
So that's that newest update to the EPA 608 standards. So yeah, we just want to make sure that we're in compliance and we're prepared. So
absolutely. I'm Brian with HVAC School.
And I'm Craig Migliaccio from AC Service Tech.
Thanks for watching.
I hope you enjoyed hearing from Brian today, and make sure you check out and subscribe to his YouTube channel, which is HVAC School. Make sure to also check out his podcast, make sure you get his app, and actually head over to HVACRschool.com for a bunch of free educational resources for you to grow. And make sure you check out our refrigerant charging and service procedures for air conditioning paperback, and also our 1,000-question workbook and quick reference cards, and these are all available over at Amazon and also at our website at acservicetech.com. Hope you enjoyed yourself. We'll see you next time at AC Service Tech channel.